a domain which I have been working last 2 years, which is like machine and learning. This interesting domain was actually a part of the European Marie Curie project, which I was funded last 2 years, and probably I finished in the month of March and I joined back. So I'll tell you what machine unlearning is and why it is so important, and then how unlearning can be used as an attack scenario. So my title of talk is Machine Unlearning, How Models Can Forget by Design, and as the knowledgeable faculty introduced, I'm largely working purely, I'm a security person, so I purely work on security domains like malware analysis, then adversarial machine learning, that means if you have a machine learning algorithm, how do you hack it, and cyber threat intelligence, and primarily security of AI, especially fingerprinting large language models. So can we change the decision of LLM so that you can hack the large language models? So to build the tone of the lecture, I would like to point to the slide that you see over here, like different parts of the world where you can see there are different privacy regulations. So essentially, if you take Europe, we have something called as GDPR, which is General Data Protection Right, where the whole idea is transparency about user data. So for example, you log into a web portal, somebody who is collecting your data, they should tell for what purpose the data has been collected and how it is going to be used. So every nation today is talking about privacy. They are talking about AI being used, and especially India is also no far behind, and we are also talking about something called as personal data protection. So what is primarily covered in privacy laws? So if you talk about privacy laws, there are basically two entities. The first one is a user like us, who is basically a data owner. And the second one is a business organization where somebody is developing a machine learning model. So these two entities should work in cooperation. So the first one is right to access, which means that I as a user, a layman user who is using some business application, should inquire about the usage of data. So for example, let's say if I'm driving and let's say it's a smart vehicle and somebody is collecting my data, so I should be told how my data is going to be used. So as a user, I should know how my data is going to be utilized by the application. So the second one is data portability, which means the complete freedom is held at the user's end. So user can basically say that, okay, an organization A was using my data. Now it could be used by some other organization like B. So the user will tell like, okay, you can shift my data from A to B. So the third one is called as right to be informed. So that means whenever I'm logging into some website and somebody is collecting my data, so as a user, you should be clearly informed, like they are going to collect my data and for what purpose it should be used. And then it is called as right to be information corrected, which means that as an end user, if I want my information to be updated at any point of time, I should be given that freedom. So then the next one is right to restrict information processing, which means that as a user, let's say I visit an hospital, my data can remain in the hospital, but I can argue and I can tell the IT centers like they will not use my data for any analytics or for training purposes. So it could be there for some other use, but it cannot be used for any further processing. So that that freedom should be also given to the user. And the next one is right to object, which means as an end user, I can ask the application or business organization not to process my data, not to use it for marketing. And last two one, which is very important, which is called as right to be notified of data breach. Suppose if my data has been attacked or taken by some adversary or an attacker, then as an end user, I should be told that my data has been stolen. And last but not the least, in which we are doing lot of work now, which is called as right to be forgotten, which is Article 17 of the GDPR, which says that as a user, if I feel that my data should not be used by any business application, so the model developer or the organization should tell me that my data has been deleted, and they should give me a certificate that my data is no longer going to be used. So the last point is what I'm going to emphasize today about, which is called as right to be forgotten or right to be data erasure, which is called as unlearning. So what is machine unlearning and why it is so important in today's era? So if you talk about two big gamuts of regulations that we hear, the first one is the GDPR, which is basically being spoken and implemented largely in Europe. And then the second one is the California Consumer Protection Act. In an essence, the summary of all these privacy regulation is transparency in data handling. So if as a user, I'm giving a data to any business organization, okay, so I should be knowing how my data is going to be used from one end to the other end, how the data is being is flowing, how it is going to be processed, how it is going to be manipulated. So I have got full freedom to understand that. So that is the complete domain that we are going to discuss about, which is called as machine unlearning. But other than privacy, there is another application for unlearning. So imagine a scenario that we as an organization, a huge organization, we want to develop a machine learning model. So the first thing is, when we want to develop an ML model, we require huge amount of data, okay? And this data that we require should be largely labeled. So either the employees of the organization should label the data, or what should what should happen is the organization can take the help of some crowdsourced service like Amazon Trunk, where people are being paid for labeling data. So that is an alternative for labeling the data. But the problem over here is, like, let's say if my organization is giving data to some third party to label, the problem is we don't know the mentality of the user who are sitting in this crowdsourcing environment. They can mislabel the data. Primarily, they can introduce certain noise, or as a hacker, they can actually bring some strong changes in the data. So let's say image of a cat, which should be identified as a cat. Instead of that, somebody could bring in some small changes in the image, maybe elongating, cutting out the whiskers of the cat, so that when the machine learning model is going to learn, it learns a noisy pattern. So the most important thing about unlearning is, like, when you develop a machine learning model, and at some point of time, the organization, the machine learning engineers in an organization, they somehow try to find out that certain data carry noise. So those data points can be removed from the learning algorithm. So for that reason also, you can apply unlearning. So let's try to understand what unlearning is, and let us try to correlate with the machine learning domain. So in order to actually build a machine learning model, as what I said is, we require a data. So in this diagram, as you can see, that we have partitioned the data into two parts. So let us forget about these two objects. Let's say this is a single universe of of the data. We take this data and we basically choose a classification algorithm which will learn intrinsic patterns that are hidden in this data. So let's say I want to classify apple as well as banana, a fruit classification problem. A simple pattern or a feature the model might learn is the color of the fruit. Something that is red is an apple, and something that is yellow in color or light green in color is a banana, and also structural properties. So with that we make a model, and then we deploy this model as machine learning as service in some cloud storage. But now what we are trying to do here is, like, the data basically contains two important segments. One is something which we want to be preserved in our model. So the information about certain samples or data points should be memorized in our model, but there are certain section of information that we want to be erased from our model, because we feel that all these data points or samples are largely sensitive. So something that is sensitive should not be memorized by the model. So the whole job of erasing these sensitive data points from a machine learning model, okay, to scrap those sensitive data points from a machine learning model and to create a modified version of a model is called as this domain is called as machine unlearning. So essentially what we are trying to do is, from the original model, we want to scrap the influence of all these data points, or we want to scrap the memory corresponding to all these data points to develop a model which we call as unlearned model. So the advantage of this unlearned model is, now if you present this sensitive data as an input to the unlearned model, it will give you low prediction score, which means it will say, I cannot understand you. Rather, if I give this remaining data point, which is also called as preservation samples or retain set, if I give it as an input to the unlearned model, the prediction score will be higher, because the memory corresponding to these data points are still preserved in this particular model. So such model is called as an unlearned model. Essentially, if you try to talk it in terms of the layman's language, how you can do it is, you can just remove the data from the universe of the data and then create a model from scratch. So that means you build the model again without the presence of this sensitive samples, and such model is called as the retrained model. So effectively what we want to achieve now is, we want to build up a model where some magic is going on which will inhibit the influence of this data points. The performance of this unlearned model should be equivalent to a model which is retrained from scratch without the presence of this sensitive data point. So effectively, we want the quality of the unlearned model to be identical to a model that has been trained from scratch without the presence of sensitive data point. So this domain of creating this unlearned model is called as machine unlearning. So this is a wonderful paper if somebody wants to actually begin discussing about or want to discuss about unlearning. I think this is one of the initial literature review on machine unlearning which has gained lot of momentum in the research community, which is Machine Unlearning Solutions and Challenges from IEEE Transaction of Emerging Topics in Computational Intelligence, a highly cited paper. So we will quickly discuss about what are the different mechanisms in which we can do unlearning. So as computer science researchers or students, so we have basically two taxonomy of machine unlearning. One is called as an exact unlearning technique, and the second one is called as an approximate unlearning technique. So there are a subset of algorithms that fall in exact unlearning, and there are a cluster of algorithms that is actually grouped in approximate. So what is an exact unlearning technique? In exact unlearning technique, the whole job is to remove physically the data point from the data store. So you have a database and you find out like some data points are largely sensitive. So and somebody claims that this is a sensitive data point. So in exact unlearning, what we try to do is we try to remove those sensitive data points from the data store. Okay, so the second one is called as an approximate unlearning, and in this approximate unlearning technique, what you do is you take a machine learning model or deep learning model, and then you try to change the parameters of the model, the internals of the model, which is basically the weights or which is gradient, such that when you give a sensitive data point as an input to a given model, it will produce a low prediction probability, which is an indicator of a fact that the data point is de-memorized from the model. So approximate unlearning, what they try to do is they will try to reduce the significance of the data points by modifying or scrubbing the weights as well as the parameters of the model. So I will cover basically rather three different techniques which are very popular. The first technique, as a computer science student or a researcher, you should know Nicholas Papernaut, and if you don't know, I think you should Google and you should study about who is Nicholas Papernaut, because if you have heard about generative adversarial network or GAN, which was developed from Ian Goodfellow, so all these people come from the same lab. So this is the first work which gained lot of attention in the domain of security of AI, which comes from the group of Nicholas Papernaut, and it was published in the top security conference, which is IEEE Security, Privacy and Symposium, which is ranked A star, where the acceptance of the paper is total 8 to 9%. So the first technique that I would like to discuss today about exact unlearning is called as CUSAT, which contains 4 alphabets. The first one is sharding, the second one is isolation, third one is slicing, and the fourth one is aggregation. So this is an exact unlearning technique, which means that we have to remove the physical presence of the data point from the model. So let's try to understand what CUSAT is. So what is done in this particular technique is like you divide your data, complete data set, into some subset, and each subset is essentially called as shard. So I repeat, you have a huge amount of data, let's say 1000 samples are there, and you divide into, let's say, 4 classes, 4 bins, so you have some number of samples in each bin. So that is like the first one will contain 250 samples, second 250, and the last one 250. So every subset is essentially called as the shard. And then what we do is, like, since you have 4 subset, you take 4 different algorithms and you give it as an input to 4 different algorithms. So that means you are trying to generate 4 different submodels, and each submodels will try to memorize the information corresponding to 250 data points. So this is the first point. And another point in this particular work, what they have done is like all these submodels will be trained in isolation, which means that the first submodel will never have information about what is going in the second submodel. The second will not have any information about what is going in the third submodel, and so on and so on. So every submodels are trained independently. Additionally, we would say that every submodels are trained with the data points where there is no overlapping. So which means the first subset will never have data points corresponding to second subset. So they are always independent. So then the second one is isolation. As I was explaining, all these submodels are trained independently using the subset of data, and technically they called this subset of data as shard. And then finally, every shard or every subset was further divided into small number of batches, and these batches are called as slices. So when you develop a machine learning model, maybe you are doing now or maybe you will do it future, what you do is like you take a algorithm, you give an input and you observe the output. So this input that you give, you divide it into number of batches, and that batch over here is called as slices. And eventually what the final decision is based on a technique called as aggregation, which means like if you have 4 models, you take the output from the first model, second model, third and the fourth, and you do some mathematical operation like voting or weighted averaging, which will decide the final output corresponding to an input. So whatever I have said here in this particular slide can be pictorially understood from this diagram. So in CUSAT, you start with the huge amount of a data set, and then you divide this complete data set into some subsets which are called as shards. As you see in this diagram, in the second column you have n shard. Now you take this shard and you select a model and you basically try to train the model corresponding to shard 1. Likewise, you train the second model corresponding to shard 2, and eventually when you want to predict an instance, you take the output from each of this shard and then you perform the aggregation, which will give you the final label corresponding to any data point. So let's try to understand this concept in the case of machine unlearning. Imagine a scenario, my data is actually present in shard 1, okay? So the whole concept is my data can never be in shard 2, because we said that the data points are always non-overlapping. That is the basic premise in which this particular technique was developed. So if my data point is there only in shard 1, then what I have to do is I have to physically remove my data point from shard 1 and retrain submodel 1, which also means that submodel 2 to n will be preserved. So they are not being changed. So whatever change will happen is going to happen in this small model. On the contrary, if you do conventional machine unlearning, you will have to change you have to retrain all these models. So that means you have to retrain from scratch. The beauty of this technique is that you identify the shard where the sensitive data point is present, and then you retrain only that submodel, which means the submodel 2 to n will be stationary, and you just average the output. So that is the advantage. So if you look at in terms of computational complexity, it is very good, because we just have to find out a shard where the data is present and then basically retrain that. So that way it is very good. So as I said, the summary is that you just have to identify which particular submodel has used the sensitive data point, and then erase the model by retraining that specific submodel. In our case was model number 1. Further, how we do is like you actually, let's say there are 5 data points and the 4th one is important. You retain the first, second, third parameter. From 4th onwards, you try to keep changing. So you just have to identify the data point and the parameter, and then you keep on retraining something below it. So that is the beauty of CUSAT. So let's quickly summarize the advantage. So as I said, in terms of computational complexity, it is very good because we are not retraining the complete model from scratch. Rather, the focus is to identify a submodel and just retrain it, because then the remaining models will be similar, you just have to aggregate. Then second one is the output that you get from such a model, which is sometimes in the machine learning domain also called as ensembles, will be very good because it is following an aggregation strategy. So even if one model is weaker and majority of the models are stronger, you essentially give the knowledge from the stronger model and it will be averaged. And last but not the least, if we look at the scalability purpose, this is very good because if, let us say, I want to add a new model, I just take a data set, retrain it, I don't do a change on other part, and it's very good if our data is basically evolving. So what we try to do is we create a submodel through a new data point and attach the output to the previous one. So as every technique has got a good point, this technique also comes with a downside. There are certain limitations with this, and the limitation is something that I discussed previously, which is called as training in isolation. So the first limitation is like the whole idea in which this algorithm works is like it takes every submodel and it will say that they will be trained in isolation. So which means that whatever is going in submodel 2, some patterns that submodel 2 is learning will not be influencing other submodels. So that means if you are talking about deep learning models or neural networks where the neurons learns through interaction from multiple neurons in the same layer, such interactions are not possible. So this works on some simple algorithms like tree-based algorithm or some decision-based algorithm. But if you want to learn some complex pattern, so if you want to learn complex pattern, your interest is interaction. So if your interest is interaction, then you cannot unlearn. So that is the drawback of this particular technique. And it requires additional storage because we should know, we should keep the memory corresponding to every submodels. We should keep the memory corresponding to parameters of submodels. So this is something which is very bad about this. And finally, it is sometimes not generalizable, or it cannot give you a prediction that you always get from other model because of isolated training, because interactions are never considered in this technique. So this is a drawback in terms of the exact unlearning. So quickly I will talk about the second approach, which actually appeared again in a very famous conference. You should know and you should read the papers, which is AAAI, which is supposed to be the top conference in artificial intelligence domain, again an A-star conference. So to start what amnesic unlearning means, I would again try to summarize what approximate unlearning indicates. In approximate unlearning, the whole idea is to forget the information corresponding to sensitive data points by changing the internal parameters of the model. So here we are not removing the data, rather we are changing the parameters, or we are scrubbing the influence of the sensitive data point from some deep learning model. So what is amnesic? Amnesic is rather a state of a medical condition wherein a person forgets an event. So it's a medical condition where person will forget about something that has happened in past. So this idea is actually inherited in the concept of amnesic unlearning. But even if this is used, there are certain assumptions where this technique can work. The first assumption is that it can be used if you want to remove the influence of certain sensitive data points or privacy sensitive data points quickly from the model, which means that it is talking about removing specific data points. So that means it cannot remove a large amount of data points from a machine learning model. So at this point of time, I would like to give you an example realistically where it works. For example, let's say in Facebook, I put lot of pictures, I upload lot of pictures, but there are certain pictures of my family which I don't want to be available in the social domain, right? But Facebook would have already done some analytics through my personal data or personal images. So as an end user, I can say, okay, I have uploaded 1000 data points or images. These 5 images are critical. You have to remove it. So when you want a specific data points to be removed, which is also called as instance-based unlearning, this technique is very good. But if the requirement is all 1000 images corresponding to Vinod has to be removed from Facebook machine learning analytics algorithm, so that is not possible. In that case, it will fail. So what I'm saying is, if you want a specific instance to be removed, which you feel it is sensitive to be removed, then this will be better, okay? And that is how it is good. But if you want a class of data, a large collection of data to be removed, then this will fail. So as I said, the summary is like when you want rapid removal of focused data point, this will be better. But so the advantage is like as in the previous case, this technique will also not undergo full retraining. It will just remove the influence of privacy sensitive data from your machine learning model. We will see how it will try to remove. So the advantage is, again, it will not go full retraining, and that is why we call it as faster unlearning technique. So if you are interested, maybe you can go to the GitHub page of the code, or you can also read this wonderful paper by group of researchers written from NUS. So how things work. So don't get intimidated by the maths that is in the screen. Maybe I will try to summarize. So when you try to develop a machine learning model, you basically do a phase which is called as training, or which is learning. So in the learning phase, we take the model and we give certain data points which are called as the training set, and the model which runs a specific algorithm try to understand intrinsic patterns corresponding to the data. So I repeat, in the training, what the algorithm is trying to remember is some special features or patterns that are hidden in the data. Okay? So how does this happen? It happens through a simple mechanism. You give a data point, and for every data point you know the labels. For example, picture of a cat, you know the label as a cat. Picture of a dog, you know the label as a dog. So when you give this data point to the algorithm learns some feature and it will do some prediction. Okay? And the prediction is, if you give the picture of a cat, let's say it predicts it as a dog. So there is a difference between the actual label as well as the prediction. So until and unless the difference between actual label, which is cat, okay, and the prediction is minimized, if that difference is minimized, what we try to do is we try to change the internal parameters of the models, which in deep learning is the weights as well as the biases. So how does this happen? This training process, which is a forward pass, happens through a technique is like you start with a model, a deep learning model, which is randomly initialized by certain values, which is, let's say, weights as well as parameter. You take some iterations and you divide the complete data into batches. You give this batch of data, see the output. If there is a drastic change in the output, you compute the error and you change the internal parameter, and you repeat this process until these iterations are over and the error is minimized. So what is this error function? It is basically actual label minus the prediction. So essentially, mathematically, what we try to do in the training process is to do a parameter update. And when I say parameter update, it is nothing but change the values of the weights as well as the biases of the neural network. You adjust such that the error is minimized. And this error is technically called as a loss function. Maybe you would have studied, or you are already trained on this, or you might be studying about different loss function, and the very famous one is called as binary loss. Binary loss when you have two class problem like good or bad, and if you have multi-class problem, apple, banana, and something, then you do something called as cross entropy loss. So that is a bit mathematical, but what you try to do is this error function is sometimes called as a loss. And mathematically, what we do is we want to develop a model which starts with the random weight. So this is the random weight, and then you add some changes in the weights, and this change in the weight is used, or changes in the parameter is used in order to basically minimize this error. And what are you changing? You are changing the weights as well as you are changing the biases. And here, how do you do unlearning? So this is very fundamental part of training. But now I have to unlearn. So when I want to unlearn, I should basically know that in which batch my sensitive data points have been used while training. So I repeat, if you want to unlearn, you should know the batch where sensitive data points are used, and you should know a specific iteration where your sensitive data point is used. So what is now we are looking at? We are looking at certain batches which carry privacy preserving data, and those batches are termed as sensitive batch. So I repeat, our interest is to find out the batches where sensitive data point is participating, and we call those batches as sensitive batch, and just subtract the parameters from this complete model. So what we want to do is, from this particular model, we want to scrub away, or we want to remove the influence of data points which are participating in sensitive batch. So we define something called as sensitive batches. So as I was reiterating, what is the definition of sensitive batch? A sensitive batch is a batch which contains sensitive data points. So you have to find out the number of batches where your data point, sensitive data point is present, and you remove it. So essentially, what we try to do is we want to generate a new model which is M dash, and this model is developed from your original model, which is shown by here, which you have looked in the previous slide. From this, you will subtract the parameters corresponding to the sensitive data point. So let us say 1000 samples are there, and you just have two samples which are sensitive. So this particular loop will run 2 times, so which means you are going to scrub the weights as well as biases of the neural network twice. And this is the drawback of the amnesic unlearning. If you want to remove 1 or 2 data point, you basically perform subtraction 2 times. But imagine a scenario where there are huge requests coming from the users. So multiple thousands of users are using certain application, and they are claiming that their data points are sensitive, and they push the request to the model. So which means that this particular part, the subtraction part, will be repeatedly executed, which means that repeatedly you will change the weights as well as the biases of your neural network, which means you are doing an aggressive change of the model. And when you do an aggressive change of the model, the performance of the model on the preservation set or the retain set will be lost. So in the summary, the utility of the model will come down if you want to actually remove larger number of data points. So that is the problem with this particular approach. So if you talk about performance, so as I said, when the number of sensitive batches are small, the model efficiency is never impacted, it will be good. On the contrary, if the number of sensitive batches high, the efficiency drops because you are scrubbing away large amount of data points. So this is very good if we want to build an application where you want to basically remove the effect of some minimal amount of privacy preserving records. So it's an ideal for protecting privacy of individual records. So as I said, but if the request is large, how do you maintain the quality? So as I said, if the request is large, you perform subtraction multiple amount of time. So you change the weights as well as the parameters of the model multiple amount of time. So definitely the quality of the model will come down. So if you want to still bring the quality of the model, if you want to improve the quality of the model, what then you have to do is you have to fine tune your model again with the preservation step. So I repeat, when you do aggressive change in the model parameters, the quality of the model will come down. But if you want to still improve the quality, what you need to do is you take certain preservation data set and then you fine tune your model with those set so that the performance of model is improved. So in the summary, what amnesic unlearning will find application is when you have some small number of data points to be removed from some machine learning model, then you use them. But if you want to go for large amount of data points to be removed, then you don't use this technique. So you either have to go to exact unlearning approaches. So this approach also comes with a limitation because it has to have the memory corresponding to sensitive data point as well as the batch in which that sensitive data point is being used. So some memory has to be retained. So it requires large number of storage if you want to delete large number of data points. So that means if you want to retain the performance of the model back, so you have to retain the parameter update. So again, every technology that you have, it comes with a trade-off that either it will effectively work on unlearning, but at the cost of computation or storage. So this was one of the problem. So I will quickly discuss, I lost, let's say, half an hour, but I will give you a gist of another domain of deep learning, which is called as knowledge distillation, and how knowledge distillation has been used in the domain of machine unlearning. So what is knowledge distillation? The whole idea of knowledge distillation was conceived when we wanted to make a machine learning model which could be actually deployed in low power devices such as smartphones or tablet. So in knowledge distillation, essentially there are two neural networks. The first one is a teacher neural network, which is a very deep, a large complex model. And from this complex model, we want to create a smaller model, which is called as a student model. But the power, the prediction power of the student model is identical to the prediction power of the teacher model. So let's talk in terms of realistic scenario where you have teacher as well as a student. When you attend the classes for certain course, because you actually are trying to hear to what your teachers are speaking about some particular topic. So essentially what is happening in our regular class is teacher is trying to distill certain knowledge, and as a student you are trying to absorb it, right? So in an essence, in this disclosure, what is happening is eventually whatever your teacher is known about certain subject or certain fact, you also try to gain it. The same thing happens over here, like you start with a very complex teacher model. The knowledge of this teacher model will be eventually translated into a student model which is smaller, and this could be deployed in some devices which has got minimal memory. And this is a wonderful work which was published, I suppose, in 2017 or so from Geoffrey Hinton, which is the first work in knowledge distillation. And most of the papers or research work on knowledge distillation is built up on this. So let us try to understand how a small model can be developed. So what we try to do is, we give an input, let us say a picture of a cat, to a complex teacher model. At the same time, the same picture is given to a student model that we would like to create. And both the model will actually compute the output. So here it's shown in some mathematical terms which you need not bother about. So basically what this particular model will do is it will compute certain probabilities. You just remember like this. And these probabilities are also called technically as a soft labels. Okay? So you give the same input to the student model, and the student model will also compute the probability. So I have been saying repeatedly that the student's performance should be equivalent to the teacher's performance, which essentially means that if the probabilities from the teacher model and the student model is identical, if you subtract these two, you would somehow feel that the student has learned what teacher knows, right? So what happens in knowledge distillation is it will compute an error function which is called as a distillation loss. Basically, it will try to find out the output from the teacher and output from the student, and if the difference is large, it will change the parameter until and unless the output of the teacher and the output of the student is closer. And this mathematical function is called as distillation loss. But at the same time, what is also done is, like corresponding to the cat image, we know the true label of the cat is cat, right? So what happens now in the second part, in this student model, we will try to find out the prediction that is made by the student model, and we will try to find out the actual label, which is basically cat. If there is a difference, again we will try to minimize this error, and this loss function is called as a student loss. So what we are trying to do is, for developing this model, two error functions are solved together. One is called as the distillation loss, which means the output of teacher and student should be identical. So we repeat this process. And the second is the output of the student model and the output of the actual output, it should be minimized. So these two loss functions are solved together, and we weight this loss, which might be shown in this next slide, which is bit mathematical, which I discourage you to remember. So basically, we are eventually building a student model through a loss function, which is basically finding out the student loss and finding out the distillation loss. And somebody who is practicing machine learning, the first part is called as a cross entropy loss, which comes through this formula, which I don't discuss because I can see some hanging fruits now. And the second part is called as a distillation loss, which means that it tries to find out the output of the teacher as well as the output of the student model. So the next slide is also bit maths, which I don't want you to remember. But one thing that you should remember is, like, if you want to pursue something on artificial intelligence and security, if we are not good in statistics and probability, I think we should forget about this domain. So maths is something very integral in machine learning. So I'm not discouraging, but it's a wonderful journey to start. So last 5-10 minutes with which I will close. So this domain of distillation can be also used for unlearning sensitive information from a machine learning model. So the technique that I'm going to talk about is a two-step technique. So the first in the first stage, any data point, a sensitive data point that you want to forget, you will try to forcefully label it with some wrong label. For example, a cat will be labeled as a tiger, and I want to forget images of a cat. So what I'm trying to tell you here is, if you want to forget certain sensitive data points, you force the label, you change the label corresponding to the data points, and that technique is called as contrastive label, and you again retrain the model with the mislabel. Okay, I repeat, take the data points that you want to forget, you change their label forcefully, okay, and then you train the original model from the this particular data point. That is, you are teaching wrong information to the model. So when you do this, what will happen? Sensitive data point information will be lost, but it will actually bring down the quality of the model. So in order to improve the quality of the model, you will actually apply the knowledge distillation approach with the preservation step. So you will teach your previous model, which has forgotten the sensitive data point, you again teach with the patterns of preservation step. So again, there are two steps. So one is to forget sensitive data point. You retrain the model with wrong labels. So when you do that, quality of the original model will come down. So in order to improve, you apply knowledge distillation. That is, you take the model in the first step. Again, you try to teach the model the data points that are useful. So that is called as basically the two-stage retraining. So how do we quickly do it? The first step is contrastive label. So imagine that I want to forget the information corresponding to a fruit called as peach. What I will do, I will wrongly label it as an apple because color of both of them are basically red. So the model that you see over here, it will not have any association between peach and the label that is peach. Instead, it will remember this particular fruit as an apple. So you are trying to weaken the association between the data point as well as the label. So that is called as contrastive label, and with which the model will forget the information corresponding to the peach. So that is what we are going to do. So when you do this, this model will eventually become weak. So what we try to do, again we retrain the model with the parameters of apple and banana so that it will remember the information about the remaining set. So to quickly look at it, so we have a data set which we want to preserve, shown by the green object, and we have the one that you see in yellow color that you want to forget. And the small bubbles that you see here are, imagine, the class label. So first step is you take this model and you try to remove the information corresponding to this data point. So how do you do it? You change the association of this model. You give a wrong label. So first step is generating contrastive label. You take your data points, you just shuffle their labels. And now you take your model, you retrain the model with the wrong information. So when you do this, the association of the first data point with this purple label will be lost. Second data point with the blue label will be lost. So that means the model will forget information corresponding to all these data points. But at the downside, it will also forget the information corresponding to the preservation step, because you are trying to retrain. So after you do this, you get the first part of the model which does not remember the association of the forget set, but again I'm saying that the information corresponding to the preservation data set is lost. So how do we do it? Maybe like I will skip some maths. What you try to do in the next step is like you take this particular data set again, which you want to preserve. Now you give the input to the model and you see the response. Okay? And if the response is good, you will consider that this model is remembering the information. But if the response is bad, then what you try to do is you will try to find out the information from the original model. You will try to find out the information from this particular model. You try to minimize it. So basically you have two models. You will try to repeat this process until the output of this model, which is a student model, and the output of the teacher model is same. So to summarize, what we try to do in this approach is like you take sensitive data point, you change their labels forcefully, and you teach the model wrong information. And when you do that, you also lose the information corresponding to this preservation step, so which you want to preserve. So what you try to do, you take this data, you give it to the original model, you see the response. You take this data, you give it to this student model, you try to see the response. If the response are different, you again train it until and unless the response are identical. So which means that this original model will share its information about the preservation step set to this student model. Okay, so I think with this and seeing the aura of the crowd, I would like to stop here. But something that I can tell you what you can do in future if you are interested. So what we are doing now as a hacker. So what we are trying to do now is like we have certain open source large language models called as Quen, Dolphin. So these models are trained using certain custom data points. So what we are trying to do now is like somehow we are trying the model to forget the data, okay, in a legitimate way. And when the large language model forgets it or removes the data point, if you give a legitimate query, it will not give you the response. So that is what we are trying to do in the attacker's perspective. We create certain client queries, and this client queries appears as legitimate, and the query is to forget the data point. So it will forget those samples from the LLM, and when the LLM forgets it, it eventually also forget the legitimate data points. So that is a very good problem space that people can investigate now. Like how do you attack an unlearning model? So a model which you feel is good, can you force a model to unlearn a data point which can eventually dememorize the information corresponding to the legitimate data point? So that is what we are doing. And I think with this I would stop. And if you are really interested to hear to what we are doing, so as I said, we are very active in few domains like distributed machine learning, which is federated learning, specifically on attacks and countermeasure. And then we are working very closely on creating threat intelligence on using Telegram, as well as Instagram, and how you can understand what hackers are discussing now. Something that I have been working since 2008 is called as malware detection, like how you can actually develop strong machine learning models which can detect the malware. And of recently, we are also looking something on attacking the machine learning models by simply putting a query to it. So suppose you just pass a query to the model. So can you try to identify whether a particular data point was used for training, which is called as a membership inference attack. So now in Cochin University, with a small cluster of students in our lab and many students who are visiting us, we are solving some pressing problems on security of AI, specifically hacking the artificial intelligence model and to fool them to give a wrong prediction. So with this and seeing your interest, I would like to close the talk. I think 1% of something you would have actually imbibed, and even if 1%, I think my work is done, at least if you have understood what unlearning is, because people would have heard about what machine learning is, but when we are living in an age of artificial intelligence, and when we see that some privacy data is being used, how an organization can certify you that your data has been unlearned is something very critical. And I think there are few research institutions also in India which have been taking initiatives in unlearning. It is very few. So I think this is something which is really wonderful to start with. So I thank the head of the department and thank all the faculty members and the management for giving me this time for sharing the very little that I know from in the domain of computer science, and thank you for patient listening. And if you have some doubts or if you want to collaborate, you may write to the email vinod.p@cusat.ac.in, or you can go through my Google Scholar page where you can try to find out what we are trying to do in this wonderful domain of cybersecurity. Thank you. If you have doubts or questions, I'm ready to answer, or rather address.
Thank you, Vinod sir, for such a clear and crisp presentation on machine learning. Now I request Dr. Paul P. Mathai, HOD CSE Department, to present a memento to Dr. Vinod P. as a token of love and appreciation of the CSE Department. Now I invite Ms. Neha Begum, Assistant Professor, CSE Department, for the vote of thanks.
Good evening, everyone, respected dignitaries and my dears. It is my great honor to deliver the vote of thanks for today's enlightening keynote session on behalf of the CSE Department and FISAT. I extend my heartfelt gratitude to our distinguished keynote speaker, Dr. Vinod P., for thoughtful, provoking and enlightening session on machine unlearning, how models can forget by design. Your talk brought out of the depth of ongoing research and practical challenges of model unlearning. It also opens our minds to the future direction and their field can take and how it will redefine trust in the intelligence system. Thank you for sharing your valuable time and expertise for sparking new perspectives in all of us. Thank you, sir. Thank you all.
എന്തെങ്കിലും എടുക്കാനുണ്ടോ സാറേ? സാറിന് മറന്നുപോയോ സാർ? അത് ഇല്ല.
Students can take a tea break now and can go to the classes after 5 minutes.